Okay, I think we should begin so that we all end on time. Of course, the stipulated time is 6 o'clock, but as per all kind of such session, we normally want to end earlier so that it's more palatable as well. But we really hope that you are able to bring away something with you in the process of going through this workshop. Maybe before I begin, right? I just introduce myself. I'm Mr. Wee from Hwa Chong. That along the way, you will, in your breakout rooms later on, there will be some facilitators. So they are your peers from Hwa Chong as well. So in that sense, they will help to facilitate the discussion in the session. I think that will make the discussion go a little smoother. Okay. I also want to perhaps highlight to everybody the motivation, the reason behind the workshop. Because every year, I think we run this, we highlight to the students. So we thought we just want to let you know. It is not a one-off kind of workshop kind of thing. The reason why we are running that is because traditionally in Hwa Chong, right, we have oral assessment or what we call Viva. So for a good many years, and then along the way, we recognize that students sometimes they don't equip with the knowledge to appreciate scientific literature. So we thought that we want to have a session before the Viva in order for them to assimilate that particular knowledge. So that is actually the motivation behind having the workshop. But we do understand that most of the schools you might not have that Viva in your own school. The reason is, of course, because of time clashes, all this. So we do understand that. Yeah, but then you might be wondering, why am I here since I'm not going to have Viva? You can treat it as just an extension of what you learned in H3 to maybe understand a little bit about how research process is like and how to go about appreciating research papers. So in the past, we normally will go through the what you have already gone through in the videos. We will normally do that. But you recognize that from last year onwards, we kind of like do it a flip approach. So meaning that I will no longer be the one telling you, oh, you know, like this is what kind of paper, that's what kind of paper. But we will instead ask you to watch the video. But we do understand students are very busy. I mean, teachers are busy as well. So it is possible that quite a number of you might not have even finished watching half the video. Yeah, so because of that, then we try to bridge a bit of a gap. Because ideally over here, I hope that you have watched the videos, etc. Then I can straight away go to the Padlet. So then from the Padlet, I can go through some discussion. But maybe right now you might not have gone through the full videos. So then how can we make our learning better in that sense? So what I'm going to do, right, is I'm not going to go into the Q&A straight away, because I mean, I do recognize that, let's say if you have not gone through it, then going through the Q&A straight away might not be extremely useful. Yeah. So what I can do is that I will showcase to you, right, some of the resources that we have given you. Okay, then I will just explain a little bit, so that later on, if you are very interested, then you can go into them. Yeah, I think that is the minimum that I thought I can kickstart this whole appreciation. Okay, so there are a few. Okay, I admit that there are a lot of things to read, but I thought that I just want to show you the key essential. So this particular Straits Times article, right, the title is Prof, No One is Reading You. Okay, so it talks about, you know, an average academic journal. Actually, no one is reading it. So the journal is the publication is like kind of wasted. Because if nobody is reading it, then what's the point of publishing? You know, you publish a beautiful research of yours, right? You want people to read and appreciate your work, right? Yeah, even though it's very hardcore, let's say quantum mechanics, quantum chemistry, MO theory. But nobody's reading, then it's such a waste, right? Yeah, even the scientific community are not reading, maybe only 0.1%. Then, yeah, so does it mean that there are some jargons involved, etc.? So this is an article that was published in Straits Times that I thought it's quite interesting. You can go and take a look. I think all of you should have access to the folder. If you do not have access, please let me know. Yeah. Then a couple of years ago, Professor Low, he's actually my friend, my personal friend in university. So he's currently the executive director in IMRI. So he wrote about this thing, publish or not to publish. Then he went on to also to talk a lot about the benefit of publishing in research journals, the pitfalls, about funding, etc. Like he wrote quite a number of pieces in his LinkedIn page. If you are interested, you can go and read them. Focus largely on research publication and whether there is still value in it. Yeah, so but of course on his own, he's already quite a successful researcher. Yeah, then some of you might be familiar with this article because the article was actually shared with many of the teachers around Singapore for the past few years. So back then it's very new, but now it's quite old already. This actually came up pre-COVID. Yeah, so this article is about charting a course in chemistry. So they actually spoke to chemists in different areas just to ask them about what are the most exciting and interesting parts in research that they are very passionate about. Yeah, so you can look through it because I will not deny that some of you might be very interested in chemistry or in research. So if you look through the article, it might give you an idea what you might want to pursue in the future. You know, like research is not just about physical chem, organic chem, it's actually very specific. There could be a field that you want to go into, a problem that you want to solve. Okay, so I would urge you to go and look through it. I mean, as I always tell my students, right, you don't have to look through everything. You just look at a keyword that you are interested in. Like, for example, let's say you like machine learning, for example, AI, now ChatGPT is a big thing. Then you can just look at what has been done. Of course, ChatGPT wasn't around back then, but I'm just saying an area that is quite similar. Like for example, computational chemistry or algorithmic chemistry, for example. You synthesize compound based on computer processing first before you go ahead with the synthesis. Yeah, all these are quite important things. Yeah, so I thought this article is interesting. Yeah, so there are a few things that I thought that I just want to show you so that maybe when you are here, you don't know why are you here, you can get interested in. Okay, then of course, there is this folder, right? Okay, so I'll just show you that. So this is the folder you can access. Yeah, so this particular folder is example of scientific articles. Yeah, you can go into it, right? Then there are actually many articles. So I just label them as article 1, 2, 3, all the way until 10. I just want to give you sort of like a snapshot on what they are, like what exactly are this article and what is the difference. Yeah. So again, if you think about it, since I already sort of have a pre-recorded session, then it doesn't quite make sense for me to go through everything. But I thought I just want to go through the very, very essential ones so that at least you know what are the broad categories of scientific publishing. Okay, a very straightforward category would be what we simply call a letter, or maybe just what we call just a research paper. So normally you hear people say, "Oh, I just published a paper. I just published a communications." I think the British, they like to use the word communication. It's a European way of saying that they publish a paper. So it's usually a very short piece of article, like 4 pages long. Yeah, so basically they publish it because they want to set a footstep into the field. To tell people that, okay, look here, this particular aspect of maybe a synthesis of this compound, we are the first research group to have done that. Yeah, so that in the future, if let's say one of the methods that you use in this synthesis become a Nobel winning work or what, then you could be recognized. Yeah, so normally people want to publish in what they call a communication or letter. Yeah. An example is like Article 2 as well. Article 2 is also an example of communication. Okay, so just for your information. Then for teachers, right, especially for us when we are teaching H3, okay, I don't know whether your teacher did share this article with you. We love to share with students what we call maybe an expert view of a certain field. Yeah. So, for example, this on chemical bonding. I know you learned that in JC1. JC now H3 you learn about MO theory, right? So this particular field is very huge. So what are experts? So these are the three experts here. We have Professor Scheck, Retzpa, and Hoffman. Hoffman was a Nobel-winning chemist, computational chemist, physical chemist. Yeah. So they actually talk about like MO theory, but they use a conversational style. I thought it's very, very enlightening. Yeah. So if you're really, really interested, have a very good or some understanding of MO, slightly deeper level, you can actually go into it. Yeah, no problem at all. Okay, so just take a look at it. It's very good for teaching. Like we really love to use this, especially at the university level. Yeah, and then the final one. Okay, then you'll be thinking, where got final? You have so many, right? No, as I said, I need to really, really summarize it quickly. So it's not really final in that sense, but what we really love when we are at the teaching, right, is really we want to look at review articles. Because review articles is like a modern version of a textbook, but they tell you a very specific field that's been done, say, over the past 5, 10, 15 years now. Yeah, molecular machines is one of them. Professor Stoddard won the Nobel Prize, if I'm not wrong, 2 years ago. I think he was in Singapore for ISYF. Some of you might have came. Okay, maybe not you, but your seniors. Yeah, because he came like a few years ago. Yeah. So yeah, he actually came to give a talk on molecular machines. So yes, he has worked for like 30 years on this topic. Excellent work. So now he wrote many review articles on molecular machines. So if you're interested, you can read about that. Even at the university level, there is no textbook on molecular machines. So what do we depend on? We depend on review articles to use as teaching materials. Yeah, because these are very niche topic, can I say? Yeah, very niche topic. So it's because they are very niche, right? Then sometimes it's very difficult to find a good textbook on them. Okay, yeah. So I just give you a very quick snapshot on this, and of course there are different tiers of research papers. I think I mentioned in the video. So if you are really interested, you can go and take a look at the video and then yeah, understand the different categories. Like some papers are better than others, so-called better. They are not better higher tier, I would say. Yeah. Okay. Then also sometimes before a publication, they will come up a teaser. Yeah. So all these research articles, right, research journals, right, they also want to find ways to capture your attention. You see. Yeah, you see, you can write a brilliant article, but nobody reads. What's the use? Never mind. We get somebody to write a teaser, like inventing the nanomolecular view. See, what the teaser is only 2 pages. Very short, 1.5. And then maybe you read it, quite interesting, right? Okay, then you will go and read the actual article, which is Article 5. But when you look at it, you say, oh man, it's so difficult to understand all the technical difficulties. Then you feel your morale is not quite there. But it's okay because the teaser will just give you the gist of it. That's good enough. You know, like let's say I'm not expert in this field. I just want to know roughly what happened. It's okay. So you don't need to feel too bad about it yourself. Yeah. So research journal articles, they are also finding ways to engage the audience now. Not general public, not engaging general public, engaging the chemistry community. Because if you're a chemist, you're not expert in all areas. Yeah, you are only expert in one very tiny aspect of chemistry. You know something general about chemistry, but you don't know everything. Yeah, so sometimes they need to find ways to engage audience. Just like how teachers in school, we try to find ways to engage the students. in many ways so that you can get interested in the subject. Okay, so I think pretty much that's enough of it. I thought that now it's timely for me to maybe take a look at some of the questions you might have. I don't know. Yeah, so it's over here. I don't know whether there's any updates. So I'll just so there's only 3 questions. Yeah, okay, so for the first column, what are the common pitfalls to avoid when reading? Okay, so this is a very broad question. Pitfalls, it's very broad. I'm not sure who asked this, but you can't avoid any pitfall because it's either you understand or you don't understand in that sense. Yeah, so in that sense, I would say to see whether it is worth reading, right? Look at the abstract. Look at the abstract. Okay, maybe an example helps. So can I just go to this? You have access to this folder, people, just to let you know. This is a new folder I put in today. Yeah, you have access to it. Why is it that you have access to it? Because later on, we're going to break you all out into breakout rooms and then you can go ahead and discuss, right? Yeah, so that's the purpose of giving you access to this. Yeah, so let's say today I wake up, I want to know what's going on, right? And then I open the journals, I saw this. There's an abstract, right? And then I read, the definitely film, alkaloids, structural general strategy for making. Let's say, right, I'm not an organic chemist, for example. Okay, let's say I'm not. Then I look at this, I say, no way am I going to read this. It's totally uninteresting to me because it's all synthesis, okay? It's all complicated structures, a lot of carbons. I'm totally not interested, right? If I'm not organic chemist, I won't read this paper. Yeah, so you don't read it. You get my point? So it's like you look at the abstract. Are you interested or not? Not interested, don't read. Then some of you might say, hey, today I'm not interested, I don't read. But you are here today to learn something, right? So and you're taking H3 Chem, largely organic chem. So there must be some form of interest before you even take the course. Yeah. So I think we are at different levels in that sense. Yeah, but I'm just saying that in a real research world, there are bound to be a lot of many articles that it's not interesting to you. Yeah, so don't read it. But let's say you're not organic chemist, for example, but you are a biological chemist, and then you are interested in this particular class of natural product. Maybe it's cancer, it's anti-cancer or anti-this, anti-that, right? Then you're interested. Then good. You can actually just read it and see what have been done. Something like that. Okay? Or let's say you are just interested in a particular methodology, for example, in making this compound. You can actually jump straight, maybe at the conclusion. Okay, so this one, okay, so there's a conclusion here. So in conclusion, we have designed a general concise strategy for the synthesis of blah, blah, blah. To prove the viability, the efficient synthesis was accomplished in only 14 steps. So very good field. Okay, and then they went on to say that there is an intramolecular Heck reaction and then a Mayward rearrangement. So let's say you're interested in methodology, the synthetic strategy. Then you say, oh, okay, so another research paper make use of the intramolecular Heck reaction or Mayward rearrangement to help me obtain my products. So let's say you are not doing all this synthesis, but you are focusing on only on methodological studies, only on the strategy. Then okay, so this paper is worthy because it helps you to have some understanding that people are using it. So potentially this group of people can be using the reaction or improved version of the reaction that you're coming up with. Okay, and you notice that over here they said something like the use of 6-pot economic steps. Nowadays we are always talking about, you don't even need your teachers to tell you, you don't even need your GP teachers to tell you. You just open a newspaper, they are talking about one keyword. What is it? Sustainability, right? So atom economy is also a big term people use nowadays. Yeah, so in this case, they try to put it in. It's also their KPI, right? 6-pot economic steps. So brilliant. Okay, so everything seems to be perfect. Yeah. So does it interest you? If it does, then please read. Not interesting, then actually no need to read. Okay, so I'm not very clear about the nature of the question, but yeah, so that's how I'll answer it. How do you make sense of very messy? Again, I don't have a clear answer to this. The reason why I don't have a clear answer is because there is indeed no clear answer. Okay, can I combine this question with this? How can I effectively read and understand scientific literature as a beginner, especially I don't have a very strong scientific background? Yeah, actually, you must start somewhere. That's a very honest reply I can give you. You need to start somewhere because it is at that level. There is no simpler level. The simplest level will be the TESOL. But in the past, when your teachers were students, there's no TESOL. Research papers are like that. It's at that level. So once you are okay with reading 2 or 3 of it, then later on you just improve along the way. Yeah. So there is really no choice. It's yeah. Okay, but I can give you an example. I hope I can combine this question. Okay, so I will give you a very specific example. It's a very personal example. Can I say that? It's very personal. The reason why is it personal is because it's related to an exam question we set 2 years ago. Sorry, I need to go to the correct folder. Yeah, it's related to the exam question we set 2 years ago. Okay, so let me just open up very quickly. I'm sorry because we haven't Zoomed for a long time. Okay, now this is our prelim questions. You have access to it from your teachers. So you can try out the questions before your prelim. Yeah, so this is what we call a stimulus-based question. And usually for a stimulus-based question, right, we set it by using a real-life scenario. Okay, so what do we mean by a real-life scenario? Meaning that it's an actual research paper. It's not something we come out with from the thin air. Yeah, of course, we recraft it a little bit. So when we were setting this question, we were focusing on organic electrosynthesis. So abstract one is a Nature paper. Nature is one of the top papers. Then of course we recraft some of the diagrams, redraw some of the diagrams. Abstract 2 is a science paper. So this is reductive electrosynthesis. You know, for students, for students' perspective, right? When you get an exam question, you just do it, right? Correct? Because everything seems so perfect, right? Actually, the process of getting here is not easy, I have to tell you, because it involves the teacher behind the scene, right? Crawling through the article. So, of course, how we find the article, all this, of course, is not, you don't really need to know. I mean, not that we don't tell you, but it's not crucial in this course. Okay, so if you want to know, maybe you can ask your own teachers. But what is crucial is more of is the work that we need to do to set the question. So that also involved the teacher reading through the research paper. Can I say that? Yeah. So because it involved us reading through the research papers, right? Inevitably, there will be things we don't understand. Because it is true that even a PhD researcher, even a professor, will not understand a work very different from his field. Yeah. So there are bound to be things that we don't understand. It is a gospel truth. We cannot lie. The person who lie to you will say, I understand everything. It's not possible. I think no one understands everything. The reason why no one understands everything because some of the information are not written out properly. Can I say that? Yeah. So this is really what this particular student was asking. The student said, what are the common, how do you make sense of a very messy and convoluted piece of literature? So how do you make sense of it? Very simple. Email the prof. Yeah, email the prof. Yeah, so because we need to set a question, right? So we need to make sure that whatever we discuss, it makes perfect sense, right? I mean, let's say I don't understand the research paper. I cannot be asking you a question. Because if you write me an answer, I also don't know whether it's correct or wrong, right? So I must have above, or rather not just above average, but a very good understanding of what's going on. Yeah, so of course we have the habit of really asking everything. So and the papers isn't very clear. Sometimes the research paper has mistakes. So it is our role. Let's say you are very interested in a certain reaction. You can just email the prof. They will answer you. If you don't believe, you can see all the email exchange. These are real. I mean, they are real email exchanges that happen over a few days. And it's 5 email exchanges. And even the prof was very, very fascinated, very interested in my research work. Actually, it's not that I'm supremely interested in the research work. It's more of like, because I need to set a question, I need to know that what you're writing in your research paper is correct. Yeah, sometimes they do make mistake. So they do answer you, trust me. You see, this is a long email reply. They do answer you. It's not like they are not going to hide behind the wall and say, no, I don't want to answer any question related to my work. Yeah, because researchers want to learn as well. Okay, they want to learn from you. Of course, we don't offer them anything, but then, yeah. So I hope I can answer this. How do you make sense of a very messy and convoluted piece of work? You cannot make sense out of it. You just have to try and reread. Some of the article is actually just translated from Google. You can know because the way the sentences are being stringed together, right? Don't quite make sense to me. So or it's translated from German, Italian, maybe Japanese, Chinese, yeah, it happens. So some papers are easier to read than others. So we tend to pick authors that write well, but not everybody can write very well. Yeah. Okay, so we have another new question. To what extent of preparation should I make before starting? You don't have to make any preparation, just read. As in really, just read. If you're interested, just read. Then all the unknown reactions that are there, right? If you're not familiar, you can just check textbooks or you can Google. I'm sure there are a lot of good answers available in Google. Okay, yeah. So I wouldn't want to keep talking because it should not be a monologue. Because keep talking means I'm like dominating the whole discussion or what. Yeah. So can I check? Is there any questions that you want to ask? I think that is more important. You can just unmute and ask. Maybe in the next 3-4 minutes. I think it's more valuable if you ask directly. Yeah. Any questions? Feel free to ask. Yeah, so that is the issue with Zoom, right? Sometimes people will not be talking. It's okay. Yeah, but anyway, can I just be assured that you have access to the folder? If you do not have, can you all just solve out? Then I think Ms. Chin can put the link over there. If not, then I think it's fine. You should have access because your respective teachers will have sent you the link. Yeah. If not, I think it is time for us maybe to break out into the various rooms, maybe for discussion. So can I just share with you? Okay, I'll share screen again. Okay, just share with you what is so-called expected. Okay, so what's going to happen is that later on, right? You're going to be broken out into breakout rooms. And then you'll be given this particular, oops, sorry, this is the question. You'll be given this particular article, which I, of course, knowingly show you just now. Yeah, this particular article. Then what's going to happen is that I want to just browse through it. I'm not even saying that you have to read in detail. But I want to have a sense of the way they position the article, especially for synthesis testing. Yeah, so you notice that it always starts with abstract. Okay, then later on, they will have an introduction. The introduction usually will tell you how wonderful this thing they want to make is. Used in traditional Chinese medicine, should have this property, that property, anti-cancer, anti-fungus, etc. Okay, so they will usually tell you a very some stories about it. And then after that, they will tell you a formidable challenge. Why is it so difficult? Like since it's so beautiful, so nice, right? How come nobody wants to make it? If you want to publish this article, right? You won't be telling people that, oh, actually, a lot of people make really. When I make it, instead of 8 steps, I use 20 steps. Yeah, actually, research publishing is very, very harsh. If people already use 6 steps or 8 steps, you use 20 steps, I think they won't accept your publication because they will normally say, unless your 20 steps has some very important breakthrough, if not, they won't accept it. That's the harsh reality of research. Yeah. So normally they will try to, I won't say put down other people's work. They will try to say, it has been done before, but we offer a more lucrative or a more interesting perspective in the synthesis. That's their perspective. Okay, so they will share with you. And then normally you have a monstrous scheme. It's quite scary, but some of the reactions you are actually familiar with, believe it or not, and then you go through the whole thing. And then after that, you look at the conclusion, what have you done? Yeah, so after you are done reading through, right? What you could do, what is the next task, right? Is there will be questions for you. You can just go down and look at some of the questions. Okay, the questions are usually mechanism based. Okay, they are mechanism based. If not, there will also be some questions on asking about appreciation, like what is the main essence of the work, or what are the drawbacks of the researchers' synthetic strategy, what are the types of reactions, what are the roles of this and that. Yeah, they are very common questions that was asked in H3 as well. So that's why we also don't want the literature appreciation workshop to be very separated, from your learning of H3. We want it to be related. Yeah, so to make it related, what we ask you will be more of the direction, the role, the mechanism, and then of course the sound of synthesis. Yeah. So so in that sense, what are the deliverables for each group? To the best of your ability, you can just maybe at least go through the article in general. Maybe the facilitators can lead the discussion. Maybe just one mechanism, just pick one, and of course go through one or two of the appreciation questions. And probably the facilitators will also have thought out some interesting questions to ask you related to the synthesis. Would that be all right? Yeah, so if that is okay, I can perhaps invite Miss Chin to bring out into the breakout room, but you don't have to rush in reading. If you wish to, you could maybe take a short 3 minutes break. It's not an issue. Just tell your facils, okay? Or the individual facil can decide you want to go for a 3-4 minutes break. That's fine. And then after that, just come back at a certain time, and then after that, discuss. Yeah. So the discussion will last until. Can I just give a time? 5:30. Yeah. So we already give you the time. We don't want to say, oh, you go already, you come back in 10 minutes. No, we don't. I think it's not worth it. So I'll let y'all go and discuss, and then we come back 5:30, and then maybe we invite 1 or 2 groups to present. Yeah, and then of course the teachers feel free to just bump here and there into the breakout rooms. Teachers, you can also help your students also. I mean, not help your students, but help the students in general as well. So that we can have a fruitful discussion. Would that be all right? Okay, so at 5:30 we'll come back. Then if you have questions not related to the paper, let's say you really have a burning question on some other things, please ask as well, so that we make it more interactive. Yeah, we don't have to go through the paper. Let me just put it this way. We don't have to go through at 5:30 everything. No. If you want the answers, we can pass to your teachers as well. We can upload it somewhere. No issues at all. But I think it's more of we really want you to take away something with you. So at 5:30, if you have other questions related to lit appreciation or literature in general, please ask. Yeah. All right. So in that case, Ms. Chin will bring you out to the respective breakout. Thanks, Ms. Chin.
Welcome back. Is there I hope you all had a fruitful discussion. I mean, of course, some rooms are a little bit quieter than others. I think that's fine, because I think we all start off at slightly different levels. So I hope you don't feel too bad, or feel that whatever is given to you, the difficulty is quite high. Yeah, because sometimes it's really hard to pitch it at the right level given the nature of the subject. Yeah. So at this point, if I may just ask, is there any generic questions that you might have related to literature or whatsoever, or even related to the article, if any? I'm not sure.
Hi, Mr. Wee.
Hello.
May I ask, right, for usually this kind of scientific article-based question, how much of the answer we can find from the article? Because through the question we discussed just now, it seems like the content in the article actually does not help a lot. Basically, it's about analyze the mechanism, and this, or actually, this kind of mechanism will be fully explained in the article's contents that we can refer to.
Okay.
Thank you.
Excellent question. I can. Let's see. I'll just share screen. I think it's easier. Oops. Where am I now? Sorry. Oops. Okay. So this is the article, right? Yeah. Okay. So can I just maybe make it a little bit clearer? Maybe I wasn't clear. I mean, my apologies. Okay. So the scientific article's main purpose, right, is not to test the student or test the reader on the mechanism. I have to be honest with you. Their purpose, right, is to showcase what they have done. Yeah. So for example, this particular author, right, they managed to synthesize multi-gram scale. You know, this year the keywords is multi-gram scale. They synthesize this very complex looking natural product, multi-gram scales, from S1 all the way to 8. So they are very proud of the process. Yeah. So that is what they want to report to the reader. Okay. So we need to get this clear, because the whole motivation of this article, right, is to explain to the reader why they want to do this synthesis. Like I mentioned to you, they have a preamble or abstract to tell you, okay, we managed to do it in this number of steps, in this case 14 steps. Why do we want to go through the great length of making this molecule? Okay, because it was found that it has some interesting properties. Okay, so and then have people made it before? Yes. Various research group, blah blah blah. So many groups. Okay, what are the strategies they have used? Figure 1. Okay, so this group used this strategy, that strategy. Then, what is your value add? Not your value add, but what are the authors' value add? So like how can they value add to the research community? Okay, they do it through novel methods, as claimed by them. I mean, as in, okay, so in this kind of situation, right, let's say you are a very established member in the field, right? Then you will feel that actually their method not profound one. You get what I mean? Like you can say, I don't think it's very good, like it's normal. Yeah. Or you can feel that, wow, it's wonderful, like it's a beautiful way of synthesizing the molecule. So you can disagree, just like how you may disagree over a poem, whether you like it or you don't like it, or over a food, for example. You may think it's nice or you may not think it's nice. You know, like we all have different opinions. Yeah, but these are the facts. If you get what I'm trying to say, like they have made it. These are the facts. Yeah. So they showcase. Okay. So this is our steps. Okay. Then after that, they try to tell you what are the value add they have provided to the scientific community. So what are the value adds? Okay, we done this and that. So they are trying to describe, like, it's very descriptive. Yeah. Then at the end of the day, then they will tell you the problem they face. Okay. I mean, I forgot whether they tell you, but I'm just saying something in general. So usually they tell you the problem they face, blah blah. And then after that they say, okay, whatever the case is, we have made it, and yeah, so this is what we present to the scientific community. So this is a report by this particular research group. Yeah, so you can treat it like this is a scientific report of their research group's achievement. Okay, then you'll be asking, then what is our purpose? Okay, our purpose, because we are doing H3, right? Correct? Yeah. So on your end, right, you will be interested in, for example,
in scheme 1, right? How does reaction 1 occur? You get my point? You will be interested in that. Then you might be asking, but I don't know. It looks like you don't know, but if I give you a little bit of clue, like whatever is given in the question paper, then you can draw something, like you can explain something. Then that's what we are trying to tell you. You can do something about it. Yeah. So that and then you'll be wondering, but the researcher, do they need to know how to draw the mechanism? It's a yes and no answer. Not all researchers are equally proficient in mechanism drawing because they come in at different levels. Yeah, but as the let's say you are a very proficient organic chemist, for example, or a computational chemist. When I show you this reaction scheme with a certain level of proficiency in the subject, you should be able to propose likely mechanism. Should be able to, but I'm not saying it's absolute. Like you can say, I think it should be like that because of this and that. Yeah, so that's the whole process. Of course, the researcher, right, when they report to you their work, they don't have to show you, oh, S1 to 1 mechanism is like that, 1 to 2 is like that. They don't have to do that. Because the aim of the work is not to do a mechanistic study. The aim of the work is to showcase the final product, whether can make or cannot make. That's why they didn't show you the mechanism. And that's why we are here. Yeah, we come in to say, okay, students, you have learned all your organic chem, all the H3, right? Let's apply. So if you go to university, you take a year 2 or year 3 course in chemistry, right? It is likely that they will actually ask you a mechanism straight out from the paper. Yeah. Then are there papers that showcase mechanistic study? Yes, have. It's just that it's not suitable for our discussion today. Yeah, because our discussion today is linked a little bit to the H3 curriculum, which is related to organic synthesis, organic mechanism. So that's the whole purpose. So there are research papers on mechanistic studies alone. Yeah, just for your information. I may not have answered the question in total, but if I can interpret the question correctly, that's what I can share. Yeah, is there other questions? Maybe I ask my facils, our facils. You were talking very passionately just now. Anything you want to share? I mean, yeah. What's your, because okay, some of you might be wondering, are the facils is it rigged? No, they were informed quite last minute. Actually, only yesterday that I briefed them. So they are as fresh as yours. The only advantage they have is 1 day. Yeah, so don't also they are given the article beforehand. Yes. Yeah. Isaac, you have anything to your thoughts, your reflection, if any? I mean, can be honest, not happy also can say not happy. It's okay.
Not really anything in particular. It's just that when it comes to this type of like seeing a reaction scheme and trying to figure out the mechanism, it helps to have more experience in like knowing what a particular reagent is usually used for to be able to guess what they are trying to go with. And also, and even if you don't, like, it's just a good idea to just like stare at the functional groups that are present in whatever reactants, rather than trying to interpret the reactants as a whole, because it can get very overwhelming with that. It's easier to like break down based on the individual functional groups and thinking how they might react together.
Okay. Yeah. Thank you for that response.
Okay, let me see. What about any thoughts?
Yeah, I felt it was like super enjoyable. A very good arrow pushing exercise for me as well.
Oh, okay, but how about facilitating?
Facilitating. Yeah, good to know like everyone's thoughts on the same matter. Cause like even with like one reactant, maybe we have different ideas on like what the reactant will do. Like maybe it's substitution, maybe it's addition. But it's good to like, yeah, as what Isaac said, like look at the final product and then guess from there. So yeah, it's good to have like many hits on the same problem.
Okay, thank you. Or maybe I can ask the students from another school, if you don't mind, to maybe share your thoughts. If you have any thoughts to share.
Hello, could you hear me?
Sorry? Yes.
Sorry, okay, so it was quite interesting. I mean, to get to look at like those kind of very new kind of journals in this chemistry thing, and like to look at what we learn in history really gets in like real life, where people start to do experiment and others. The discussion was a bit dry just now, I guess, because maybe most of us are introverts, but quite meaningful, and some of the questions were like, it's not very difficult, but it's like getting the context and trying to analyze and think of it may be a bit difficult to process. Yeah.
Okay, thank you. Okay, thank you very much for all your inputs and feedback, especially to the facilitators. Then I think we also don't hold you all for too long because it's a Friday. Yeah, but Miss Chin and I, and of course the H3 team of teachers, right? We will definitely value your feedback. So Miss Chin will be sharing a link with you all. I'm not sure whether it's going to be a link or yeah, there's a link. Perhaps you all can share with us some of your honest feedback regarding this particular session, because as some of you might be aware, there is actually a face-to-face session on Tuesday. I mean, it's going to be the same thing now. The only reason why you are probably here is really because of the distance lah. Like it might be a little challenging for some of you to reach Hwa Chong, say within half an hour to 45 minutes lah. So we decided to do it over Zoom, as per previous 2 years due to the pandemic lah. Yeah, so we would really value your feedback if you could share with us. Let's say if given a chance again, right? Or maybe for your juniors in the future, right? Do you think this kind of session is better to have it face to face? Yeah, I mean on site, or if let's say distance travel is really an issue, do you think Zoom will still work as well? Yeah, so that I mean this kind of feedback help us, because if let's say all of you say no, don't do Zoom, never do Zoom again, because can face to face. Yeah, then next year we won't run it through Zoom. We just say everybody come face to face. I think your feedback is very valuable to ensure that your future batches of juniors will benefit from this whole session. Okay, would that be all right? So we thank you very much for your feedback. We'll still hang around for a while in case you have questions to ask. So once you're done with your feedback, then you are free to go. Okay, yeah, thank you very much.